So what looks familiar about this one? Sorry, that was going to drive me nuts. I couldn't get it to work. The numerator is the same as the total number of degrees of any polygon, right? And then we're dividing it by n, which is the total number of sides or total number of angles. How come this has to be a regular polygon now? This doesn't work for just any polygon. It has to be a regular polygon. Why? Because all the angles at this point are going to be congruent. When you divide it by n, you're saying that all the angles are going to be congruent at this point. So this has to be a regular polygon when you divide it by n. Okay? So for the example that I give you right here, is that a regular pentagon? No. Visually, all the sides are not congruent, and then they give you angles. The angles are not congruent. Now, how would we find the measure of angle y? Do we know how many degrees are in the pentagon? How do we find how many degrees are in a pentagon?
N minus 2.
That's right. We're going to do n minus 2 times 180. We're going to use the very first formula that we talked about. That's how we find how many degrees are in any polygon. It doesn't matter if it's regular or not, right? So you're going to say 5 minus 2 times 180. So what's 3 times 180? So there's 540 degrees in any pentagon. There's 540 degrees. Okay? So we've got 540 degrees out right here. Now we know that 110, 90, 120, and 150 are already in there. So we just need to subtract all those from 540 and what's left. So angle y here is 70 degrees. Because you subtracted all those out from the 540. So like I said, it's a real simple thought, but you do have to know this in order to get that. Now, you would not have used the formula that we just talked about just a second ago because all those angles are not congruent. Any questions on what I've said so far? Okay. The next thing right there on your sheet is talking about exterior angles. So this is called the exterior angle theorem. This is telling you that the exterior angles always sum to 360 degrees. So no matter if you have a triangle, a quadrilateral, a pentagon, a hexagon, an octagon, a decagon, it doesn't matter how many angles you have on the outside, all the exterior angles are going to sum to 360 degrees. Why do you think all the exterior angles are going to sum to 360? What else sums to 360? Circles, right? So all the exterior angles sum to 360. So all your exterior angles are forming a circle. Like if we were to take all them out and we were to put them all together and make a vertex there, they would all form a big old circle. Okay? So let's look at an example with that. So here's a pentagon. If we were to take all those together, add them up, they would sum to 360. So let's look at the example on your sheet right there that has the measure. It wants to know what the measure of angle 1 is. I don't know why this thing's running so slow. Now this is a regular octagon. So it says, what's the measure of angle 1 in the regular octagon at the right? We really don't need to know any of the inside angles right there. We don't need to know any of the interior angles because we know that the sum of the exterior angles is what? 360. We know there's 8 of them, so what do we need to do? That's right, 360 divided by 8, and what do you get? So 45 degrees is the measure of each one of those exterior angles. So that's how you would use the exterior angle theorem. Now we could find the measure of one of those angles on the inside. How could we find the measure of one of those on the inside? if I wanted to use the other theorem.
Oh, you take 180 minus 45.
Yep, we could do that. I could do 180 minus 45 and get it. If this right here is 45 degrees, I could say 180 minus 45 because these two form a straight line, right? And what's 180 minus 45?
135.
You're handing me a pretend sheet?
No, can I have a sheet?
Thank you.
You're welcome. Can I have that? Yeah.
You can't have two.
Oh, okay. Thank you.
What's 180 minus 45? 135. So you could find the measure of an interior angle that way because these form a linear pair. Remember talking about that in Math 2? How those right there would be consecutive angles. You talked about, let's see, corresponding angles. What else did y'all talk about? Alternate interior angles. Do y'all remember talking about those in Math 2? Man, that's been a while, hasn't it? That's been a really long time for me. It's been, what, a year for you? Maybe 10 for me. Not old.
You just pretty much called yourself old right there.
No.
And you say you're not old.
I did not. I'm still in my 20s. Thank you. So,
How many years have you been teaching?
I feel like you're
You don't look like
I said I'm in my 20s, so you better watch yourself.
How many years have you been teaching? Wait, what age did you
I'm on my
graduate?
7th year.
You're on your 7th year.
Okay, what age did you graduate high school?
So she graduated high school when she was 18. She had to have 4 years in college.
Mm-hmm.
You're like closer.
She could be 29.
You're almost 30. You were talking about how you were going to turn 30 this year.
Mm-hmm. Okay, we're done with
So
this
you're almost-
conversation.
You're pretty much